Oh, seems to be working better.
Okay, cool. So you can, from the green button, you can share your screen, and I can switch to your slides and presentation
Okay.
once it actually works.
Should we fire up our presentation?
Yeah, it's fired up.
What's it going into? Which cable is it going into?
The white one.
Okay.
Sharing the screen. Yeah, I want to do that.
Yeah, just that screen.
Is this a Thunderbolt?
Yeah, it is.
Yes.
Well,
Shame
I'll-
with
I'll-
all our slides.
Ultra high resolution. It's
Going to be stretched.
going to be massive.
What's going on?
It's coming. Yeah, it crashed.
That's sad.
Yeah, I'm not sure it's gonna support.
So we've got a couple of chaps here from Growth Intelligence, Alex and Francois. So welcome to the stage, guys. Thank you.
Thanks, Jan. Yeah, evening, everyone. So I'm Alex, this is Francois. We're going to talk about how we use Elasticsearch for predictive lead generation at Growth Intelligence. So Growth Intelligence is a predictive marketing company. We generate predictive leads. So we track the activity of every company in the UK, and our customers give us a training set of their customers, people they previously sold to, and we build a machine learned model of those customers and use that to basically rank how likely our customer is to be able to successfully approach every other company in the UK. So they use our tool to log in, they build a marketing campaign, they call it down, and they give us the feedback. So we get the success or failure in each of those leads. That goes back into the tool, and that model is improved iteratively over time. We work across a number of sectors, so the customer is at the bottom of the slide, unfortunately, but we work with FX brokers, so Cambridge Mercantile Group, banks such as Barclays, email marketing firm Pure360, the telco BT, and Google as well. So we work with small and enterprise companies. Just to zoom in on one, Pure360 use our software to better identify companies that are sending large volumes of emails. So their product is an email marketing service. So they need to find companies that are sending tens of thousands of emails mostly to consumers. So we've got sort of three main layers to our technology. We gather data from a range of sources. So we scrape companies' websites, we plug in some APIs, and we have news feeds and other feeds that we ingest. We organize that data into signals that relate to particular companies, and it's those signals that we use to build our predictive models. So an example of one of those signals are what we call bills of lading. So every time a container ship goes into a port, there's a manifest for the goods that are on that ship and are unloaded in the port, and we can tie up the exporter of those goods from the UK against a UK company, and that means that, well, that's a useful signal, for example, for a company that has a foreign exchange requirement. So if someone's exporting, probably dealing with foreign currencies, and that's the kind of feature that we put into the models. Right at the bottom again, unfortunately, is sort of our tech stack. So Elasticsearch, Python, scikit-learn does a lot of our machine learning, and we're kind of largely Linux-based. This is just a screenshot of the tool as a user would see it. So the blue column on the left gives them all their search filters and basically the option to slice and dice all the data, so they can look for recent sales triggers, such as a company that's just exported something, as I mentioned, or if the company's recently launched a product. They can segment their market by the sector that the company works in, or what they produce, or how they sell. They can do a keyword search below that, and off the bottom of the screen, they can search by company age and size, this kind of stuff. And then what they'll do is export the leads from this tool, call them down, as I said, and the feedback comes back in, and that machine learned model keeps improving over time. So we're going to talk really tonight about why and how we use Elasticsearch. We use it across the piece for storing and analyzing and processing raw data, up to our feature generation and exploration, and then actually up to serving the tool as well. So Francois will talk about the first of those kind of use cases, and I'll talk about the second two. And really just to emphasize the point that we use Elasticsearch from back right to front. So the raw data comes in, we analyze that in Elasticsearch, that gives us features. Those features go into machine learned models. Those scores are scored go into Elasticsearch. Elasticsearch serves up the web app, and we're also now starting to introduce Kibana and use that to hopefully better refine our product and cut some of the waste out of it. So, Francois, if you want to.
Thank you very much, Alex.
In the remote.
So I will take you through our workflow and our data flow. So there are a couple of important steps, and which are storing and processing raw data. So this is upstream. As Alex mentioned, we gather raw data from the web, which includes web pages that we crawl, and we've developed an asynchronous web crawler in Python that delivers us web pages. So a few requirements for our storage solution. We needed something that we were comfortable with to be able to rapidly adopt and integrate into our backend. So that was very important. We needed to store those web pages, which were coming at us very quickly, with metadata in terms of ID, of date, and we wanted to run queries on that data to not have just a black hole for our data, but also be able to slice and dice it and run queries. And for that, we're using Elasticsearch. We're analyzing the incoming data in a couple of different ways: a standard analysis, and also an analysis which strips HTML to be able to only search the visible text. So for that use case, we basically use Elasticsearch as a document store, and we really care about speed. We care about being able to retrieve documents easily, and we care about the robustness of that database. And that last point led us into a little bit of trouble and some obstacles to overcome in terms of memory consumption. So that was something to watch out for. But now we have kind of iterated on that and solved it mostly. We don't really care about many of the traditional database criteria or features, such as rapid consistency. We are just writing into Elasticsearch quickly, but we're not doing reads as well as writes at the same time. So we don't need a truly transactional data store where you have all your data available, and you have always the full data that is searchable. So we can have a bit of lag, of delay. And we are not doing updates. We're always writing, we're always inserting, and we're not updating documents. And we don't truly care about backups. We care a little bit, but we don't have that hard requirement. So we've compared a few solutions. Our first version, our first iteration, relied on flat files. We just dumped our crawled web pages onto flat files. And as we are crawling millions and millions of domains and many more in terms of pages, we have that many pages on a drive or on a file system, which is very slow. So Elasticsearch, just writing the pages for Elasticsearch gives us that benefit of not having to worry about that many files. We've also evaluated a couple of other solutions like MongoDB and CouchDB for our raw data store as well as other use cases, and they have different features, but basically Elasticsearch has everything we need from a document store. MongoDB, for example, has MapReduce built in with JavaScript. You can pass your jobs in JavaScript. CouchDB has a very neat versioning system of documents. So we might use those for different use cases, but basically we were very happy to go with Elasticsearch for storing our raw crawled data. That data is analyzed in a couple of different ways, as I mentioned. So we have written our custom analyzers. The cleaned version uses the HTML strip character filter, and then we are doing a few other things, but it was really interesting to be able to tweak the way the data is analyzed. The only caveat was the memory issue. So this is our use case is very much using Elasticsearch on a single machine. And we talk a lot about clusters, but that was early in the development of our web crawler. So it was very much an MVP, kind of internal product. So we wanted to keep everything on one machine, and we wanted our Elasticsearch process to be always up and running, obviously. But we have a variable input, and that input, that data comes from the web. It could be arbitrarily large, so we have to control the input because if we try to index too much at once using the bulk API, we use the bulk API because it's much faster than just sending individual documents. And you have to be a bit careful with the size of the bulk you send to Elasticsearch. So yeah, to kind of protect and make it a bit more robust, we use Supervisor to always have the process up and running, and we use a log table to log any exceptions, anything that goes wrong. We have a log of that. And that's in our Python program. We log the traceback and our custom exceptions. Now that we have all that data stored, I'm going to talk about the second use case, which is batch processing. We have tens in the tens of gigs or 100 gigs. So we need to go through that data, run experiments, run very simple scripts on that data, which are mostly about processing the text and aggregating the text. Same as before, we needed that to be up and running very quickly. So we needed a technology we were confident with. And we also needed the ability to scale, because obviously that's data that's piling up. And so we wanted to plan for the future a little bit. To go through all the data, we used the scan and scroll API, which is very efficient. And those are the native endpoints. You have a scan endpoint, and you send a query. Then you have the scroll endpoint, and you receive and pass hashes to get chunks and batches and pages, basically, of results. And it's much quicker than your traditional pagination. That is wrapped in a very nice helper. In Python, you have the Elasticsearch Python library. It has a scan function, which basically is very simple. You pass the query. You don't have to worry about handling the batches. You just have an iterator, and then you iterate through your results, and you're kind of oblivious to the batches. To process our web pages, while processing our web pages, we hit the I/O limit of our hard drive because we are I/O bound. It's not a CPU intensive process. So we needed to do fewer reads. Obviously, with our millions of files, that wasn't really working. And we often hear about Hadoop for that kind of work. And basically, you can split that work and parallelize it on several machines. And we're not using that. We're using Elasticsearch instead of a cluster and a Hadoop paradigm, MapReduce paradigm. So the read performance, we evaluated that scan and scroll API against our initial solution of one file per page. And it's much faster. It's about 5 minutes to go through a batch, for example, of 3,000 files. It's 15 seconds with the scan and scroll. If you have all that data in one file, obviously it's very fast, much more efficient. But then again, with the scan and scroll API, you can pass a query and work on a subset of data instead of going through your whole data set. And that makes it very attractive for us because we have questions that we are trying to answer, which generally require a subset of the data and not the whole data. One example is when we want to see which companies are using certain frameworks, because that could mean that they have a modern website or a mobile-friendly website. So it's interesting for us to know which companies are at that stage or are brand aware. And to look at the frameworks, the JavaScript frameworks, we first need to have that script tag in the HTML. That's kind of basic, but we don't even need to process the pages that don't have that script tag. So we pass that script tag to our query, and Elasticsearch returns us a subset of the data, and we can run then regular expressions and more complex processing. So there could be limitations going forward. This is very much a lean, early stage solution, but it was out of the box. We were able to deploy it very quickly. We were kind of familiar with the hardware setup we needed. So that was very convenient, very good, and the performance is great with those kinds of data sets of tens of gigs or even hundreds of gigs. And we've done in the past a multi-machine architecture with a message queue, but that wasn't really needed in that case. So that's our basic lean data workflow. The main point is that we didn't go for Hadoop or didn't go for a cluster, but rather used Elasticsearch and the indexing, very efficient indexing and querying of Elasticsearch, very small overhead in terms of our operations. And Alex is now going to talk about training set and models.
Thanks, Francois. So we're a bootstrap startup. We work in 2-week sprints, so try to keep ourselves as lean and agile as possible. So I'm going to talk about a few examples of how Elasticsearch has allowed us to do that, basically, and work very efficiently. So when we start working with a customer, we normally have a couple of weeks to get something out in the wild and working for them so that we can start that process of learning. So the first example is how we dealt with noise in our data set of companies' websites, basically. So noise in this case is things like error pages or default server pages or domain registrar pages. And within each example of these, there's a lot of similarity. So an IIS page, default server page, looks much the same, whoever hasn't configured their server. And 123.reg looks much the same, whoever hasn't configured their website. So I guess the intuition was that by running a fairly general query, you'd end up with a lot of pages that scored pretty much the same, if not exactly the same. And then when you line that up against another facet of the web page, so in this case, content link, which we've logged, we like taking logs, you end up with these hotspots, essentially. So the arrow that's pointing out there is a hotspot of, for example, many IIS pages that aren't configured. And what that allows us to do is to build a set of rules that we can eliminate those pages from up front, or put that into a machine learned model to predict which other hotspots or pages outside this space we might also want to eliminate. And again, that's just a quick bit of work in Elasticsearch, which gets us an awful long way. The second example is just to bring to life really what Francois mentioned with looking for a script tag. So this is part of a training set that we got from a customer, and I guess we had a suspicion that their customers would be companies that were fairly brand aware and brand conscious. So we inspected the websites and became clear quite quickly that they were fairly trendy, I guess you could say, and that then they were also driven by fairly up-to-date, fairly modern JavaScript text and other text. I'm not a front-end guy, so I'm kind of on slightly dodgy ground here. But and then it was fairly easy from that, and using the method that Francois described to run basically a query over the rest of the data set, pick out the companies using those similar texts, and that's a feature that can go straight into a learned model. So it really, from my point of view, it was query to feature, in in next to no time at all. The second example of this kind of feature generation that I thought I'd talk about uses the term vector API. So what we did here was to line up all the websites of companies in the training set that we got from a customer against the rest of the universe, or the shard, I suppose, and calculate the relevance of each of the keywords extracted from that training set versus the relevance of that keyword on the shard. And what you can see on the left is that there's a pretty decent correlation between the two. So most keywords are as relevant to the training set as they are globally, which I guess you'd probably expect. But then when you pick out a particular topic, you can see that topic is quite a lot more relevant to the training set than it is globally. And in this case, this is actually 200 or so company names. So it goes back to that example I mentioned earlier about companies with a foreign exchange requirement. This is actually a training set of companies that need foreign exchange services, and so it's probably no surprise that country names are more relevant to them than they are globally. And so we could go straight from these two measures of relevance to a feature that we can again apply to the whole universe, just using a couple of scripts over the term vector API. So it's another example of how quickly we can go from a bit of intuition to a feature that we've engineered over 1 million or so websites. The last thing I'm going to talk about is how Elasticsearch allows us to resolve the tension that we have between a user's intuition and what a salesperson who's using the tool thinks works and what the data is actually saying. So when we start with a new customer or in a new segment, there's often no training data available. So not all of our customers are able to release that training set of people they've worked with before. What we can do in those cases is encode some pretty simple business rules into Elasticsearch. So we can get rid of companies that it's impossible for them to work with up front. So that might be companies that are too young, or don't have sufficient assets so they can't be lent to, or don't have a decent enough credit score, that kind of thing. So just some simple blacklisting, really. And that leaves a sort of space, really, where there isn't enough data to do any sort of machine learning on, but the customers have this intuition that they've built up over their sort of sales career. And that has led in the past to a pressure to develop these definitely overcomplicated Elasticsearch queries, which overfit the problem and are hard to maintain, interpret, and understand. So, I mean, it's pretty obvious early on that this wasn't the right answer. So we backed away from that, and we have to convince people that the best results are gained when a general ranking, machine learned ranking, is combined with their user queries on the fly. And what the Elasticsearch, the query DSL, allows us to do is just allows the users to express their intuition and their sales knowledge and their sales skill in the tool at really next to no cost. So it's really great at kind of resolving that tension. The other thing that Elasticsearch allows us to do via the tool is to kind of nudge users to building a better campaign. So as they're applying all their filters and their searches, each of the leads, the companies that are still, that they've selected, are scored. So the top ranking leads, I don't know how many people can see this, the top ranking leads are green, then the sort of okayish ones are amber, and the red ones aren't even displayed. So as a user's building their campaign and cutting down their universe of companies they want to call, if the top lead is amber, they know they've got a problem. And so the tool is trying to push them away from that campaign and encourage them to hopefully build a better one. There we go. Great. So just to summarize, 3 main reasons that we use Elasticsearch. It allows us to be lean and agile. It allows us to iterate and explore over data incredibly quickly and go to features that we can put into models incredibly quickly. And it's helped us resolve this tension between the users and salespeople and what the data's saying. So just to carry on a theme, we are also hiring. Get in touch at jobs@growthintel.com, or speak to myself or Francois afterwards, and there's a couple of other guys in the audience as well. So Python, data scientists, Elasticsearch, that kind of stuff we're interested in, and we'll take any questions. I can't comment on our benefits package, I'm afraid. So yep.
You're getting your data from web scraping.
Yeah.
Are you also monitoring any news feeds or any time stream data?
Yeah, but it's probably not as critical as you might imagine, I guess. So we do read about 500,000 news articles every day, but actually, in terms of the value add to the customers, it's not as great as you might think yet. So that's probably probably harder for us to get the value out of that than we need to at the moment, if you see what I mean.
When you say reading 500,000 news articles, you do it scraping them again.
Yeah, so CTO's answered on my
Yes.
But we are classifying on the fly all that news feed and all those articles that come in. We classify them and trying to extract the events of what they are about.
So many
but we don't store them in Elasticsearch yet. So that's why.
Are you using the percolator for that or something else? Or?
No,
No, we're not using Elasticsearch for that. We will probably incorporate that stuff into Elasticsearch.
Do you want to come up?
Sorry, I'm sitting. Who's that guy?
Yeah, I don't know. It's crazy.
Backseat driver.
Yeah. Follow me, lads. I'm right behind you. Anyway, anyone else?
Yeah.
Oh, hi, Mike. Yeah, not too bad.
Jessica Matthew.
Yeah, indeed.
Your Spider, does it do any kind of directed stuff? Peter will know this. Having a spider that stays on topic, as it goes through the web, and when it reaches a dead end, it kind of doesn't see any more content related. Is that something that you?
I'm trying to.
Yeah.
Yeah. So I think we've had more success being probably more directed, like I said, than trying to be too general.
Right.
With crawling and scraping, I would say. But we're not necessarily worried about topics up front. We can be a bit more selective, or maybe less selective. I don't know, but yeah. Yeah.
You've touched on it already, but how much of the web pages are you storing in Elasticsearch?
Everything we get. So.
yeah.
But the entire content you're stripping out some things, or you?
Oh, we're storing everything.
Do you mark it up yourselves, or do you just leave it as?
No, we leave it. So we analyze it. We want to be able to search for tags or properties, or through the raw HTML. But we want to also be able to search the visible text on it. We have those two analyzed versions. But otherwise we're storing everything.
It's all done kind of after it's stored. So those features aren't tagged up as the website is ingested. It's done post that.
So are you storing Elasticsearch and then analyzing it and then restoring it, or are you storing it somewhere else in the meantime?
Yeah. So I guess we don't necessarily restore it. We'd store the relevant information. So whether a company is using a particular framework or relevance of keywords. So it's not the.
It's boiled down to a very manageable data set at that point.
So the first POS of ES data you've got there, that's the raw data that just goes in as documents. So that's the raw HTML.
Yeah.
And you have a process that extracts features out of that
to
then go kind of further down the chain. So the original data, the raw HTML, how are you just storing that verbatim? Do you have a custom analyzer chain? I mean, what are you doing?
We have a custom analyzer, which isn't really mentioned here. That's just the schema. But our custom analyzers are very simple. One uses the HTML strip character filter, and then we have a few more, but it's fairly simple.
Okay, because I mean, cleaning up HTML to kind of get the visible text out of it is
it's tricky.
Easy, but
it can be.
Okay.
it can be tricky. Yeah.
But searching for things like script tags and if that goes through the analyzer, if you're not careful, then the words on the page could be undistinguishable from a script tag where
That's true.
So do you do any special behavior around that, or?
No. I think we considered that an edge case, and we didn't worry about it.
If I were to write a scraper today, I'd look at the Cheerio libraries and Node. What is that?
Cheerio.
Cheerio in Node.js.
Okay.
Sure. It does a full Chrome browser in the background, so it resolves the script tags for you.
I think that's our next step to let pages. Execute the JavaScript.
Python comes in first, but it's good understanding.
Wow, we're popular. Why don't we start over there? And
What's the operational overhead of running a big web scraping operation like? Does it break all the time? Do people block you?
yeah, we've definitely developed it iteratively, I suppose you could say. I mean, we've been working on it for a couple of years, I guess. We've had a couple of false starts and tried some libraries that haven't really worked out. And I guess what we've ended up with is something that is quite bespoke to our needs in terms of we can pick and choose where we need to scale. So we can be quite selective. So actually, I think we've probably got to a point where we're quite settled, and it's not too bad really. The overhead, I guess,
it doesn't put pressure on the servers, so what kind of run robin thing if you like, we're not hammering servers or.
That's something, yeah.
You said that you classify everything you scrape. Is the feature from the classification they are predefined, or you automatically discover them?
It's a classification process.
So, the feature of the classification of the groups, they are auto-discovered, or
do you mean for the news articles, or do you mean in general?
In general, for everything you scrape.
So I mean, the news articles, that kind of powers the search triggers bit at the top on the left. So that's a predefined set of events that could make an approach to a company more effective. So management change or product launch, that kind of stuff. So that's predefined. In terms of the other features, yeah, I mean, generally at the moment that's intuition from the training set or from our experience. I mean, kind of the feature engineering side, despite the efficiencies we get from Elasticsearch, is still sort of barrier to scaling, because with a new customer or a new segment, there still has to be a man in the loop there. So as our dictionary of features gets bigger, I suppose that problem can fade, but it's still relevant at the moment.
So when you find a new feature, how do you reclassify all the existing documents?
Yeah, well, that's what we need to do.
How do you do this? You have a big batch process.
Well, it's the kind
So there are two levels of features. There's the macroscopic level where we want a model to score on results, and we have text features for text classification. So I guess there are two different levels. So in terms of classifying news articles or websites, that's kind of standard text classification, which is, but it's fairly standard. From that, we have more microscopic features about companies in general, and that's where most of the machine learning comes from. Is that fair to say?
Yeah.
So in your flow, you had sort of two Elasticsearch steps. The first one and the second one, three. So the first two, when it comes in as raw data, this is replacing like a distributed file system, right? Yeah. And then when you requery to apply features or to train models from it, when that data goes back into Elasticsearch, is that in new indexes or in new clusters, or?
Yeah, it's new indexes. Yeah. So I mean, I suppose that the top one is web page centric, essentially. I suppose, but the second and beyond that are more company centric. So that's an index based around features we have for a particular company in the UK.
So your initial raw data set is kept long term, it's growing larger all the time, whereas the remaining indexes can be tailored to client specific queries. Do you run those in the same physical Elasticsearch cluster, all those indexes, or
different machines?
Yeah, it's different machines. So I mean, the last one in kind of production is obviously is separate and stuff. And then I guess it's actually called raw data. To be honest, there's a raw data server and then a dev server. It's kind of business. That's what it's about. Anything else? Sweet.
Thank you very much. Thanks very much to Alex and François from the Growth Intelligence. So for the final session of this evening, I'd like to welcome some of the developers from Elasticsearch for a Q&A session. So this is your opportunity to essentially get free support. To ask questions of any nature, particularly on IC, of course. Yeah.
Yeah, what's wrong with IC?
Cool. Thanks, guys. So, does anybody have a question to kick it off?
I'm curious about how customers are reacting to Kibana 4.
I think what's happened with Kibana, well, from our perspective anyway, sort of core developers, we kind of move things on a pace we felt in the back end with aggregations.
Yeah.
Kibana 3, because it was using facets and just that one-dimensional view of the world, we kind of felt a little bit disappointed in that Kibana wasn't showing the world what we were capable of anyway. Kibana 4 is now addressing that, and it can surface so much more of the functionality that's in there. I think people are kind of beginning to get a real sense of some of the more advanced things they can do with it, and I think overall it's very positive. I mean, even to the extent where they don't care too much about the fact that because it's undergone such a change, we can't honour and load up the old dashboards that they made in Kibana 3. And there are some organisations, I think, where they've rolled out Kibana 3 across the whole company and everybody been saving away their own little private dashboards. I see that as potentially, the biggest cause of concern for some people, and potentially the retraining that goes on around getting your head around Kibana 4. It does have to walk this terrible line between being easy to use, but also surfacing a lot of complexity and a lot of power. So it's a bit of a tough thing, but I think they're doing a good job on having little bits of it that drop down here for the advanced stuff. So you can, I quite like it because we can still place in bits of raw JSON, that we know will help make things better in certain cases. So it's nice that they're catering for us as well. But overall, it seems to be very positive, and a lot of people just can't wait to get their hands on it in GA.
Yeah.
Shield. I've seen Shield's been launched, and I want to know about what that looks like in reality and production, what the overhead is, and how it integrates. Is it something that runs within?
So it's a plugin that you install on Elasticsearch. So in that respect, it's just like any other plugin. You install it onto your nodes in your cluster, and you've got kind of you can draw from kind of the authentication and the authorization kind of features that it provides. In terms of actual performance hit, there will obviously be a performance hit when you're talking about encrypting data between nodes. Personally, having not worked on the development of Shield myself, I don't know what that figure is, unfortunately. But yeah, I mean, you can appreciate if you're encrypting traffic, you get an overhead, you've got to do the encryption, and that costs CPU time, right? So yeah, I mean, I don't know whether you can add anything.
Yeah, I mean, I think for the moment, because we're limiting ourselves to saying users can't access a certain index or a certain function, it's not that invasive in terms of an overhead. When we move towards document level filtering, this user can see these individual records. It's perhaps not as scary as you might think, because it's stuff that we've done before in another context in Lucene, and at the end of the day, it is just another filter. The things that we use all the time anyway, the bit sets that kind of filter things out, less than this price, can see, can't see, it's another filter. So that's the next sort of phase where we address another level of security and access control. But we've been there before, and we've implemented things like that, and it's just, as I say, it is another form of filter. So that's when be an extra added concern is for every single document you're kind of making these checks, but that's the sort of thing we do all the time anyway in filtering.
Yeah, I was worried that document level ACL within Elasticsearch as a plugin would just load everything, but
it ends up being. I mean, we haven't finalised, how it's being addressed. We're not part of the Shield dev team, but when we've implemented those sort of things before, it's based on you hold properties on the documents, and it ends up just being another filter that you run to say only documents where security level is greater than X, and you're a member of group Y, and so on.
That's a related question, really. I mean, bearing in mind you're introducing security features into Elasticsearch now, are you going to have any kind of third-party testing of this? Because there's a...
So we did. So actually, we have had a third-party firm who took the Shield plugin and tested it for us. That happened previous to GM.
Has that been published as a...
Honestly, I don't know. I haven't heard of anything, but then, like we said previously, neither of us are actually involved directly in the development of Shield, so I wouldn't like to say yes or no to that one.
Yeah. I mean, there are certainly places that are very serious about security on there who are kind of waiting for this stuff.
And I mean, the beta period for Shield was quite an extended period. I think the beta period started in October, so it's gone to a good 3 months of quite a few customers getting hold of it and thoroughly testing it. It went off to a third-party firm who put it through its paces from their point of view. So
yeah, we found some issues with all the clients that we have with the beta thing that came out of that process. So yeah, it's had a good time kicking in. Yeah.
I'm guessing even if you do publish it, you're not underwriting the need for third-party pen testing for complete solutions.
We're not underwriting the need for no.
Well, I mean, you're
not. As in, we're not going to say that you don't need to pen test off.
Right.
Given the number of things you could do deploying Elasticsearch to open it up to somebody to attack. No, right? I don't think any software vendor would say don't bother about pen testing our products when you deploy it yourself. But like I said, it has gone through its paces in terms of product testing. Anyone else?
What about our memory issues? And do you think it's uncommon, or do you think it's a
This is your big payload thing, is it? Very uneven sized things.
Yeah.
So, yeah, the way we define batch size is, I believe at the moment, is it number of documents you put in a batch, right? Yeah. So a lot of our users are kind of sending roughly the same size things, well, certainly from the logging community, and everything ends up being the same size thing. So yeah, there are definitely cases, I guess, where you would have to, in your case, figure out that actually I've got to be sending 3,000 docs, not 5,000 this time, because I know that one of them that I scraped off the web is enormous. Yeah, so maybe just for the moment at least, it's your client code that has to kind of deal with those discrepancies in document size. There were some changes in this thing recently that we found tripped up some customers along the way, which were kind of necessary things. We found people were putting terms into the search index where there were things like base64 encoded images. So not a white space in the whole thing, one big token, and that was being stuffed. Lucien was quite happily saying, yeah, we'll index that, almost great token, sat in the search index. Nobody would ever search on this thing, right? So I think quite sensibly, Lucien put a thing in that said, bigger than 32K, no one's going to search on it. Yeah. And it was a hard limit. It feels like a reasonable one, to be honest.
So a very generous one.
Very generous.
A single term of 32K is pretty generous.
So yeah, we did have some customers who experienced some issues where they were indexing 32K or bigger than 32K terms, which is these crazy kind of situations with base 64 engines and things. And so we're addressing these things as we go along, I think.
So it's more the client's responsibility to check.
For now, the bulk of the requests, unfortunately, sorry.
Would things like rivers help in that situation where you're not sending a batch which then has to be held in memory, but the river's doing it independently?
We use the R word.
What's the future of that?
For those playing catch up, rivers architecturally, we're of the opinion these days that we don't like to run kind of arbitrary third-party processes doing arbitrary bits of processing, like connecting to JVDBC databases. And we've even got one. I sort of came across one the other day. I didn't even realise we had it. We've got one which is called like an attachment plugin. You can send us a stupidly sized PDF or whatever, and we'll fire up Tika and try and parse it. You remember our issues with Tika years ago, right? You give it something that looks like a spreadsheet, it's trying to treat it like text, and it will just get into this endless loop and blow up. We don't want any of that crap in our Elasticsearch servers, which is supposed to be there running solid indexing, searching. We don't want these going down. So we don't want these kind of rogue components that can be thrown a wobbler by some crazy bit of data getting bogged down with this stuff. So that's why we're trying to push all this kind of river stuff upstream, if you pardon the pun, and make it part of ETL. And it could be Logstash. If you don't like our ETL framework, use another one. But it's stuff that's to do with content preparation. We want to draw the line and say, you give us JSON and we'll do a good job with it. But connecting to a variety of different.
Though where the app, if you could actually send a pre-analyzed document through, you'd solve half the problems.
Pre-analyzed document.
I'm not sure Rivers solves that, because you still end up with the thing.
No, but you don't have a batch of potentially lots of them.
Yeah.
Right. Yeah. Generally speaking, the device is probably we expect you to give us good JSON, not crazy. Yeah.
Good JSON.
But yeah, I suppose it's something that's something that could be thought about, something that could be. I mean, if you haven't already raised a GitHub issue on it, it might be worth raising a GitHub issue. It's more likely to get fixed if developers on Elasticsearch community and business know that the problem's there explicitly. I mean, obviously we now know because you presented it to us, but just as a wider issue, it's more likely to get fixed if everybody knows.
I'm not trying to dodge the issue, but what is it that turns up that you crawl from the web that's kind of enormous that you actually want to keep?
It's only what Francois said earlier, which is, unless we dynamically change the chunk size, if we end up saying chuck 1,000 documents in, and 100 of those documents happen to be larger than the average document size we were expecting on a one-off chunk, we might end up exceeding the.
So you're not talking about one page which is stupidly big. You're talking about just the chunk just happens to be bigger, like on average bigger than.
Yeah, because we're using the bulk API. That's what it boils down to.
So I mean, I think some people sometimes fail to anticipate the extraordinary. When you're dealing with large volumes of data, you get the extraordinary. So one of our customers was it's one of these top apps on the website. I can't remember what it is, but basically it's a study guide. And people publish a list of flash keywords and the whatever it is, the definitions of these things. And it's a game, and you have to guess what the definition is, or tie them up or whatever. And they hadn't anticipated that somebody would load up an entire encyclopedia as one of these documents. And people do this stuff. Yeah,
I mean, we had a page that just never stopped returning. I mean, it would generate more and more stuff.
Yeah. So I always think it's important, to have these kind of sensible, put these limits in, like the Lucene thing. Nobody's ever going to want to search anything bigger than 32K. I think we should have one internally in our cluster state objects. I don't think we should ever entertain the idea of a cluster that's got more than 50 million unique field names in it, because this is state that we pass around. So I think when you design these systems, it just makes sense to set what the stupid limit is and make sure your code enforces it.
But I think also, like, maybe I'm not saying this is the way it will be approached, but maybe the first solution to that would be, okay, at the moment presumably we're going out of memory when you say we crash.
Yeah.
So the first step might be to install the circuit breaker on the index, on the bulk index API, which doesn't actually solve the problem explicitly for you, but at least it tells you, hey, you've streamed too much to us, we're shutting down the connection or something like that. So just to kill the request before it gets to the stage where the cluster's brought down by it.
Yeah,
but that's difficult.
Try that with a Python streaming bulk client. Just propagates the exception, and it doesn't. So normally with the streaming bulk API, most exceptions it will just yield. in the generator, and then you can carry on. So you just fail to index those documents and carry on, which is quite nice. But for memory exceptions, unsurprisingly, because it's pretty fatal, it's not going to.
So do you know whether this is happening on the client side or the server side? Is it happening before you actually send it to the server? Or?
No, it's the server that causes the
memory exception. Right, okay.
But that's because probably we should. I mean, we deal with it now by just having a smaller chunk size or varying chunk size or whatever. But in theory, if we got an exceptional thing, we may still encounter it, I suppose.
Yep.
But yeah.
But yeah, definitely raise an issue on GitHub. Absolutely, with that.
Yeah, I'm sure you're aware about the work that a guy called Kyle Kingsbury is doing around the distributed systems, and in particular did a massive article on Elasticsearch and the consistency or the lack of consistency in Elasticsearch. Is there anything you guys are addressing on this?
There are lots of things we're addressing in many different aspects of the platform. And it's an ongoing process, and we now track our status on that. There's actually a webpage, elasticsearch.org/resiliency or resiliency status.
If you search on the Elasticsearch website for, I think it's resiliency page, it should
resiliency status. Resiliency status. So, I mean, to be fair, we got a bit of a kick from that thing. I'm not sure all the aspects of the configuration were ones which are recommended ways of configuring the platform. When we came back with the set of things that we'd done and we'd addressed and were addressing already, we already had a GitHub issue open for the things that were the subject of that. And we're very public about where we are and what we're doing, and the fact that certain things are going through, like, for example, the Lucene code repository to fix in extra file checking format checksums, throughout everywhere. And we've seen there's a whole collection of things that are to be addressed. And Carl came back and said, he was very complimentary about the fact that we were actually being very open about this stuff and recognised the work that we were doing there.
That page is constantly being updated, and not only are we constantly making fixes to that page, but we're also constantly adding, this is something that we want to work on as well. This is something we want to work on as well. So it's an evolving page. It's not an exhaustive to-do list. Yeah.
So, I mean, from my point of view, it's always been. I mean, technically, I've always found it quite reassuring that Shai, who, the CTO of the company, the original founder, has always publicly said, don't put your mission critical stuff in, as we're not ready, for this stuff. There's a number of things we need to check off along the way. But databases don't achieve this kind of level of robustness overnight. They take many years of development to achieve these statuses. And it's quite refreshing from my point of view. It's being driven not by a marketing department saying, yeah, sure, come and put all these stuff in here.
Definitely. But now
there's technical people who know what they're doing.
Version 1.0 is already gone, so it's about
I mean, it's funny, yeah. I mean, the company we used to work at, we put products out there and we would label them 3.0. The first release, just because it was kind of, from a marketing perspective, it seemed better. Whereas Shai actually was holding off from putting out a release that he would attach the 1.0 label to, because he didn't feel that we had, all the boxes ticked for things like snapshot and restore and backup and recovery. So he saw that as something to aspire to, not something to move beyond and get into, selling and peddling software as if it was mature rather than when it really was. So, I think there's quite an honest and open agenda here, but when it comes to how we present our technology and where we are.
I'm going to look at, I'm particularly interested into the Zen Disco and the cluster management stuff, because I've seen it very real behavior with multiple masters and nodes that disappear.
So 1.4 got a big upgrade of the Zen Discovery stuff. Around a lot of different areas, but also specifically around the types of split brain issues that post in particular was talking about, where it's not a complete network partition, it's a partial network partition. The basis of the problem there was a partial network partition between nodes. The Zen Discovery module got a big upgrade in 1.4 to help solve those kinds of issues.
In fact, that was one of the first releases, I think, where we don't normally do betas. We have very extensive testing internally of the core platform. So just continuous integration, random chaos monkeys running around changing all sorts of things behind the scenes.
Not to mention that there's various people in the community who are running code off unreleased branches as well to fix issues and to test and stuff as well.
But those changes for that discovery thing, because they were an important set of changes that needed to go in, that was the first time we actually, I think, ran a beta ahead of actually putting out the GA release of 1.4. So yeah, there was quite a bit of re-engineering going on to address those problems. So it's stuff we take very seriously, yeah.
What's on the cards then for the roadmap for the next next release? Is there, well.
So I can tell you a bit about 2.0. I'm working on a feature at the moment, which is essentially kind of taking aggregations to the next stage, if I wanted to put a marketing headline on it. Basically, take the output of aggregations, maybe you've got a histogram, and do some post-processing on the buckets, not on the documents, but on the buckets. So do things like, at the moment, you can't do a derivative of a histogram. So let's build something so you can take the output of your aggregations, and just before we ship it back to you, we calculate a derivative over all the buckets. Moving averages, we want to try and do some stuff around predictive analytics. They're starting to look at, and also anomaly detection. So looking at things like change point detection, anomaly detection, things like hot winters was the term that was banned around this week, I think, internally around, this would be a nice thing if we could do. But basically building a framework around taking buckets and doing post-processing to either add information or complete. So there's kind of two steps. One is you take the output of an aggregation and you do some computation on it, basically destroy the aggregation but create a new one, which is essentially what derivatives would do. Very rarely do you actually want to plot both the derivative and the original data, especially on the same histogram. That doesn't usually make sense. And then the second one is more around, say, the anomaly detection, that kind of thing, doing either adding buckets or adding information to buckets or to aggregations in general. So you say, this bucket in my histogram, this has got an anomaly. Mark it with an anomaly, tell me what type of anomaly it is, I don't know, tell me the scale by which it's anomalous. I'm not a stats person particularly, so but you know, tell me what's wrong with that point, or you know, if we're doing predictive, then here's the histogram, and by the way, we've added what we think would happen in the next 3 months, type thing. But all using, so we're, in terms of the algorithms, we'll be using like standard statistical approaches to this, but actually going on top of aggregations. So that's one.
Is that feature got a name yet?
Ish. It would start off being called bucket reducers, because essentially you're taking the reduced phase of aggregations and you're doing work. The derivative, and sort of the thing where I said about taking buckets, destroying the original aggregation, creating a new one, we've called transformers, but I don't like it. So that's probably going to go through a rename. Yeah, so we haven't really got hard and fast names about it. But yeah.
Twitter has an interesting GitHub.
Yes, I saw that. Yes. Yeah, I saw that the other week. Yeah, we're looking at that as well.
If I may suggest also another feature that would be useful is typically, you ingest raw data, you do some sort of pre-processing, and then you put your data into Elasticsearch. So what happens if after a certain while your processing changes, you have to go back and reprocess the raw data. So as the data starts growing, you reprocess the data with a normal flow and reindex the data in a completely new index or a completely new cluster. Is not a scalable solution. It would be better to have extracted the index of Elasticsearch as a library to be able to be used like in a Hadoop job, so that you run you reindex everything as a part of the Hadoop job, and the result will be produced in just a free-form index that you can just then give to.
Well, I mean, I guess there's ways of doing it. I mean, there's clients which will do the re-index for you in that you can say I want to take the stuff from index A and I want to put it in index B.
Yes,
Index B could be something that you stand up temporarily.
If you want to reprocess raw data and you have 100 terabytes, that is the problem.
Yeah, there's a lot of
You
network
need to
traffic.
do a completely replaster and start hammering for 3 days and build a hoping that it's.
Well, if you think about what you could do, you could transfer all the data over a network anyway to stick into your Hadoop cluster or whatever to build that. If you stood up a temporary set of servers, Elasticsearch servers, go very wide on it, perhaps, index it all out and that.
Yeah, but
and then
you need the full set of things. What you need is just maybe the part of the entire Elasticsearch which created the index. So the index are bit.
So that
everything
mine,
else
the canvas is like one of the core Lucingo, the core Lucingo in my book. He's actually looking at some stuff at the moment around adding a supplementary field to an existing index without having to re-index the whole thing.
Yeah,
I mean, that's very early days.
You really have to re-index the whole data.
Well, this is what he's trying to change.
Yes.
He's trying to add a capability where you can supplement and add a new indexed field on after you've already indexed it.
Because Lucene is made of immutable segments. It would be better that you extract the indexing library out of Lucene, out of Elasticsearch. You put them as a separate library that can be used with Hadoop to generate immutable segments. But then once they are fully built, you just send them to Elasticsearch and say, look, this is a new index. It doesn't have to do anything. Just
what's the difference between a temporary Elasticsearch cluster doing that?
It's a full Elasticsearch that needs to be installed, configured, put the storage in place. While if you need to run a job, you can spin up a 50-node cluster on EMR, give it the library, it's going to produce the result that you need, and then you go back to your original cluster. You say,
well, I think we saw a demo of spinning up multiple Elasticsearch servers earlier, right?
Yes,
yeah, I mean, you can do that.
It's an additional effort, putting all these things in place, and I'm sure the Elasticsearch, as a whole, as a cluster, is optimized for both workloads, while you don't need at all a certain type of workload, like the query bit.
I remember going and seeing various people talk about how they built their Lucene. I think it might have been in a server context they used to do that and build their clusters, and then they would push them out. So I know that people do those kinds of things. I mean, I think a lot of the justification for keeping things free of Hadoop for a lot of things is that it's less infrastructure for people to have to install. You may well have a big Hadoop cluster.
You spin up a cluster on the cloud, you don't have to have an Hadoop running all the time. That's the point. I have to reprocess all my historical data, 100 terabytes.
So all the mechanisms, if I spin up an Elasticsearch cluster, let's say I can script it to an extent where I can do that and fire up an infrastructure, and I fire the content in, and then you've got the ability to then say, and now I want to migrate these nodes for, allocation awareness, I want to put them on this other machine, all the migration can happen. So all the APIs are there already to do that kind of thing in a pure Elasticsearch setup. It's just maybe the scripting and then the provision of those, those things.
Yeah. Well, I don't think there's any particular problem with, like, the index a bit. It's not, I don't know, like taking out the index a bit of Elasticsearch wouldn't be quite as simple as just going, there we go. Like, there's a lot of stuff that's around cluster management stuff, and actually a lot of Elasticsearch is around the management of the shards, and you still have to produce all the shards separately, because if you produced just one shard which was one index, we'd have to take that index and rip it back apart again and basically rewrite the entire.
That's what I said. So the index is able to produce just the index and the shard already pre-built, and then you can ship that. If you know, there is a tool, a new system, it's called the Druid. It's a new real-time analytic system that does exactly this. There is a real-time indexing node that accepts the data and pre-build immutable chunks or immutable segment, and then they ship those segments back to the index and to the query node, which they just query immutable segment node. And this is a much That's much
I
easier.
think other systems before, when they tried to separate out the indexing activity from the search activity, I think part of the problem with this is that there's a fundamental tension between two different concerns. On the one hand, when you ship these changes over, you want to ship over the smallest unit possible of what you need to get it over the network, right? The other tension is that from a search perspective, when you're putting lots of content into a searchable pot, it's better to have one searchable pot than lots of tiny little ones. So that's what the merging process in Lucene is all about. It's trying to limit the number of segments that are created. So if you're using replication of segments as the basis of distributing changes, then there's that fundamental tension there. The unit of what you were transferring over the network has that kind of problem, basically. Yeah, so that's one of the downsides with that.
It sounds as though there's a generality of the mechanism. It sounds as though you're talking about a more real-time situation where you've got daily content going in, and yesterday's history doesn't change, it's yesterday's history.
Yes, I think the fundamental problem is if you have huge amount of data and hundreds of terabytes, and you have to reprocess or reindex all this data, how would you go about it?
I think there is probably an optimization to be made in the clients that allow you to re-index and they say, get me all the content from over there and put it over there. They essentially take something which could be very wide in terms of shards and put it over there, and somewhere that's very wide, but then channel it through a single node as they're kind of pulling the data from there and sending it over there.
Yeah,
so that's potentially a benchmark. So you could potentially have something that was more efficient in terms of streaming from each node.
Not necessarily from Elasticsearch to Elasticsearch. I'm talking from file in S3 to Elasticsearch. You have your raw data, you want to rebuild your cluster. How do you do that?
Well, and you say you put it into a job that just builds the Lucene index and run it in Hadoop. I think part of the problem is that there's a lot of kind of all the Elasticsearch mapping definitions and everything else, which kind of layers on top of raw Lucene. You have to recreate all that kind of.
The other thing is, if you're actually just recreating the index verbatim, you're not doing anything different with the index, then why not use snapshot restore?
No, I mean,
you've got no processing.
You've got two processing. Like you do enrichment or analysis of the data before, so the raw data gets processed and then you index the enriched data as the raw content.
I mean, if you were having to revisit your content because you were having to revisit some aspect of the ETL, like your enrichment with GeoIP or something like that, you'd be having to pick through your ETL stack anyway.
Yes, exactly. But one thing is if you have a real-time stack, and as the data comes in, you ingest them and you process the new index. There's a few hundreds of gigabytes a day, maybe a terabyte. But if you have to go back past 6 months, suddenly you have hundreds of terabytes. You don't want to spend maybe 5 weeks just to index.
Yeah. I mean, it's going to take some crunching, wherever if you've got some jobs running in a Hadoop cluster, or you've got some jobs running on Elasticsearch nodes doing it, it's still a lot of crunching.
Yes, it's easier to scale.
We have that problem a lot. We've got a 10 petabyte data storage thing. We keep data for as long as we've been in existence, 5 years or so. And probably 80% of it is unusable then, for much of those reasons. But I think that's one of the problems with scale. That as your software stack moves forward, you have to face that choice, whether or not we bring history up to date so we can use it in the same platform, or whether we leave it behind and effectively save some money on our data centers.
Yeah, this is a different discussion.
Yeah, I think it's difficult to handle in a very general context.
No, I think the problem is specific. You got data that you need to reload. As the data volume now starts to become bigger and bigger,
yeah,
I think Elasticsearch is stayed a little behind on how to ingest quicker, higher volume of data. Compared to other tools, that's it.
Sorry.
would you say Elasticsearch is trying to become good at storing text, or good at storing text, good at storing numbers, or good at storing text and numbers?
Yeah, I mean,
I'm thinking like in logs. There's logs and there's metrics, and Elasticsearch is great for logs, but we also put metrics in it. Is that the right thing, or?
Yeah, I mean, we came to this from a text background predominantly, and one of the big surprises to us was just how much people are using it for logging and unstructured use case. So, I mean, personally speaking, you know, I've tried to bring along things from the text world. Stuff you do in Alex with significant keyword spotting. Did you use significant terms for that, or did you look at that? Or?
We couldn't really get that going with kind of the free text, so that was just term stuff.
So yeah, that's an example of something which is a text analytical function, which is pretty powerful one. But it has some constraints in that when you're doing that text analytics, there's a lot of kind of random lookups of words. What's the frequency of this word? What's the frequency of that word? And I think it's wrong in those cases to do that analytical function on all of your data, all the millions or hundreds of millions of documents that match your result. So one of the things I'm looking at the moment, and this is going back upstream, back up into Lucene, is the idea that you can work on a sample of the data, like the top ranked results that come back for your query for your company or whatever it is, and all the directors who might exist in it, get the top n matching documents back, and then run that through the significant terms aggregation, so that way it doesn't kind of just completely cane your system, and maybe analyze the documents on the fly and stuff. So it's bringing some of the text analytics that we had in previous products and things, so bringing some of those things through. So another thing relating to that is the idea if you are going to sample content, then you need, like any good market researcher, to have diversity in the sample that you take. So there's a function I'm putting into Lucene at the moment, which is probably one that a lot of people have looked for a while now, which is in my search results, if I'm going to search a whole bunch of content, let's say products in a marketplace, I don't want to be dominated by products from a particular supplier. So I want some diversity. So the rule is I don't want any more than 5 results from any one supplier. And you still get the top ranked results back, but it's got diversity. So the collection process of collecting up the documents you're going to scrutinize, it's got diversity in it. So personally speaking, yeah, there are definitely things to do with text analytics that we can improve on and add to the mix. And I think one of the questions is whether or not we try and keep those things as part of the aggregation tree, or have a completely kind of separate text analytical endpoint. There are benefits to putting it inside the aggregation tree, because you can use the aggregation tree to break things down by manufacturer and all that sort of stuff. So one of the examples that I had was you break down all your products by manufacturer for your fault report database, and then you analyze the text of the fault reports, and it'll tell you exactly what goes wrong with each of the different car makes and models. But to the extent where you actually then glue the text back into phrases rather than thinking of them as individual words. So there's a bunch of things that you can do in text that kind of are different to the normal sort of analytics you do on structured stuff, and sometimes you need to work with samples and things like that to be scalable or to not blow up. But yeah, there's a number of things that I think we will definitely continue to maintain those text capabilities and the heritage.
And I think there's so many people using both sides, or one side or the other, or both sides of that text or numbers, that it wouldn't make sense to fall down on one side of that. It makes sense to try and support both going forwards. And actually, there are lots of people who do actually have a mix of the two, and mixing the two is pretty useful sometimes.
Well, I think that's where we fall in. It's less efficient to store your metrics and your logs in the same place, but by hell it's convenient, because you can say, look at the error and correlate it to the latency, and it's just in the same place. So,
well, for me, one of the greatest things about all this stuff is that all of the things that we put into Lucene to support text search and relevance ranking, IDF and those kinds of things, they're all underpinned by the idea that we have to actually count the frequency of every word we index. The reality is we actually count the frequency of everything we index, not just words, but numbers and everything else. And you can use that stuff to do all these things like anomaly detection and things like that. We're not using the stats that are in the index for the purposes of relevance ranking documents. We're using them to spot anomalies of things. Because we're bloody good at counting absolutely everything you stick in there. We know the frequency of everything. And that's, for me, that feels like a massively underutilized aspect of the platform. We sat on this huge pile of statistics, which used to get used for text ranking, but now we can use it for doing anything, any kind of numerical analysis on content. We know the frequency of IP addresses and everything. Some of the stuff I've been playing around with just recently is just, I was analyzing all the traffic that's coming into my website. And I'm breaking it down and looking at, I'm trying to figure out what rules to write. Do I block a particular IP address, or do I block the subnet that contains a whole raft of IP addresses? I'm using the stats to say, well, how many times do we see this IP address in this context, 404s and all the bad stuff that goes on, versus how many times do I see it in this context, 200s and good traffic? If I get the blend of the two, I can find all the IP addresses that seem to have a skew and a mix towards the bad rather than the good. If I roll that up into a traffic flow, I can see at various different points in the subnets where there's high concentrations of risk coming into my web server. And I can start to tune into the different areas where risk is kind of accumulating via these various different conduits up to my website. That's just using all the stats that are in the index. And I think it's the sort of thing that we're benefiting from all the features that are there for text, but for doing unstructured stuff.
I just spent the day at a real-time analytics conference in Kensington, and Elasticsearch was mentioned as an aside. The search generally was an aside. Most of what I said to guys there just went completely over their heads, because the stuff they're using is still a very early look at analytics. It's all those old BI tools and stuff like that, which don't get us at all. There's a massive opportunity there to change the world in real-time analytics.
Yeah. Okay.
Thanks very much. Big thanks to Colin and Mark there for Q8, and thanks to all our speakers this evening. Very good talks, and also of course Roger for the beer, the pizza, the venue, and the live stream. So grab some beers as you go, grab some more pizza, and we'll head to the pub afterwards. Are you going to throw books?
Yes, and for our 4 speakers and our hosts, we've got first editions of Pete's book, The Elasticsearch, so if you want to come forward and